Wonderful. Welcome, everyone. Let's see. We are really excited to have you guys here. My name is Rebecca Warren. I lead product marketing here at StackHawk. And we're really excited to have you here for our webinar on integrating application security into CI/CD. With me today, I have two wonderful hosts. The first is Zachary Conger. He is a senior DevOps engineer here at StackHawk. And also with me is Andrew Way, who is a senior sales engineer at Armory. And they will be walking us through the presentation today. So with that, I'm going to go ahead, get out of the way, and pass it over to Andrew to get us going.
Great. Thank you. Thank you, Rebecca. So today's goal is we're going to show how to ship secure code faster. Essentially, we're going to be integrating application security scanning from StackHawk with a Spinnaker pipeline. So let's first kind of walk you through what we're going to talk about today. We're going to set up an Armory pipeline that deploys a rock, paper, scissors app, and we're going to run a StackHawk hawk scan against that app. And then we're going to show you a little bit more details about Spinnaker as well as StackHawk, and then we'll have room for questions. So first, let's talk a little bit about what you're going to see in action. So we're going to submit a PR later to GitHub, which will create a container, kick off that pipeline, do the scan, and then deploy to Kubernetes. First, let's talk a little bit about Armory. Armory's vision is to unlock innovation by making software delivery collaborative, continuous, scalable, and safe. Armory is built on top of open source Spinnaker, which provides expertise as well as additional features and functionality, as well as third-party integrations. Today, we're going to show off that StackHawk integration.
Well, thanks, Andrew. So StackHawk builds a scanner called HawkScan, and it's a dynamic application security test tool, and it's a CI/CD friendly DAST tool. DAST is the acronym for that. Since marketing threw this in on me at the last minute, I feel compelled to mention that fixing bugs when they've hit production is the most expensive way to do it. So you really want to shift that left as much as possible. You can shift it left all the way to the coding practice, which is where we're focused. You can really reduce the cost of finding security bugs considerably. So when we looked at the development landscape, we find that there's a lot of tools out there now for the development process that help the developer through the whole process and make their jobs easier. If a developer checks in code that has the wrong syntax, it's not going to compile, and their IDE is probably going to let them know about it before that even happens. If they've got a conflict with other code in the repository, they're going to get a merge conflict, and it won't merge. If there's a logic problem in their code, their unit tests are going to fail. If there's a problem integrating with the platform as a whole, they're going to get integration test failures. But if there's a security bug that they introduce, there's nothing that's really going to tell them in real time, and that's what we're trying to address. So what is DAST and why should I use it? So there are a number of static analysis tools out there that will check your code that are kind of CI/CD friendly. You're starting to see more of those. And DAST differs from that in that DAST doesn't have a language dependency. It doesn't care what language your code is written on. It's more of a black box tool. And it deals more in the context of how the application works. So if you have vulnerabilities that a static analysis tool might find, the dynamic scanner is only going to find them if those code paths are actually exposed and present in your running application. So it works by probing a running application and examining the outputs of that application to see if there's evidence of a security vulnerability. And as a result, it tends to have lower false positive rates. If a DAST tool, such as ours, finds an issue, discovers an issue, it's likely to really be present in your production code. Our scanner can find, and other DAST scanners can find, things like SQL and OS injection issues, cross-site scripting problems, and other content security policy issues. So what we do is we want to find and fix security bugs in your CI/CD pipeline. And that's something that's unique about our scanner, is that it works really well in a pipeline, as opposed to others, which can be difficult to instrument. They can be difficult to even run manually, but they tend to be focused on manual operation for penetration testing. So we want to find those security bugs in your application. We want to help you triage those findings and reproduce them. We want to help you manage those findings and have the scanner remember those findings from scan to scan, so you can be alerted when new issues come up, and understand the security profile of your application as you've worked on it over time. This is just a quick preview of the StackHawk configuration. So like a lot of modern tools, it's got a YAML configuration file. And just focusing on those first 3 lines, the key components and the only ones that you really need to get started are an application ID, which is a UUID that's assigned to your application by our platform when you set it up in our platform. The env setting, which is the environment that you intend to run it in. So given that we're centered around CI/CD tooling, we figure that you'll be running this in a pipeline and you'll be targeting different environments. So your environment might be local, for if you're running it on a laptop, development in a sandbox, pre-prod, production, and so forth. And then finally, just a host, which is the endpoint that you're going to scan. You give it that information, our scanner will take off from there, spider it, discover all the endpoints that it can scan, and start probing. There's a lot of other settings that you can set: authentication, GraphQL, probing, open API spec, and so forth. But you check this into your code repository along with the code that you're testing, and that way you can track changes over time and get highly repeatable results.
Great. So now that we have a overview of Armory and StackHawk, let's jump straight to the live demo. Again, just to recap, we're going to show you a PR to GitHub, which will again create an image that will trigger a Spinnaker pipeline, and I'll talk a little bit more about Spinnaker later, that will do a scan and run in Kubernetes. Okay, so let's start with the repo that Zach mentioned. We can commit a StackHawk YAML that contains configuration. And like he said earlier, we really only need these 3 parameters: the application ID, host, and environment. You'll notice here also that we're going to use some used environment variables instead. So we'll specify that in our Spinnaker pipeline. This repo is public, so if you're interested in checking out the app, feel free to do so. And this is a quick demo of the app. So we are deploying a rock, paper, scissors app. You can play against the computer, pick your move. I pick rock, I win. Or you can, if you're afraid to pick a move, you can just let the computer pick for you too. Okay, and let's talk a little bit about Spinnaker. So this is the Spinnaker user interface. Spinnaker is a continuous delivery platform helping customers and companies orchestrate and deploy their apps reliably, consistently, and more efficiently. You're really giving developers the power to deploy into production. Like Zach mentioned, being able to capture those scans early and often will allow the developer to be more productive, catch and fix those issues sooner. We have here a Spinnaker pipeline that we call StackHawk demo with 4 stages. Each of these boxes represents a stage. So let me show you in more detail what those stages are doing. The very first stage is a deploy to dev stage, which is simply a Kubernetes manifest that describes what we are deploying. And here you can see we're going to deploy my image RPS and a service and ingress so that we can get access to it. We're also then going to run the StackHawk scan, hawk scan, after we do the deployment. So we're going to tell it where's the repo that we can go get that StackHawk YAML, what environment we're deploying into, and where is that endpoint that we're going to scan. And later, if the scan is successful and doesn't have any errors, we are just going to give you the ability to skip this man of judgment But if there are issues, we can manually come in and prove the deployment into production. Let's kick off the scan, and I will dive a little deeper into, let's do team and okay, so it's kicking off. While it's kicking off, I can show you a little bit more behind the scenes how we got to this StackHawk HawkScan stage. So in Spinnaker, we provide this ability to run Kubernetes run jobs as a stage. You might, if you've noticed, you really can't, sorry. In this stage, we've already created custom, what we call a custom run job. So that really helps teams reuse stages, makes it discoverable for those teams that are building their own pipelines. But as you get started with Spinnaker, what you can do is create a run job stage like this. You specify a manifest. And here, this is exactly what's going on behind the scenes. We're running a StackHawk HawkScan image with a script that's simply cloning that repo and running the command shock. And then because of the environment variables that we provided, it has all the information it needs to run that script against the endpoint that we've also pointed at. Okay, one more thing while this is running. Sorry. Oh, okay, so that actually already completed. So let me just show you one more thing before I show you the results. Here, another Spinnaker's value add is the ability to see all its deployments per the application. So as a developer, I can immediately see the history of those deployments. I can see I deployed 13, went back to 12, and I just deployed 14 just now. I can see the health of the deployment. I can see details on the side. So this is a kind of a single pane of glass for me as a developer to see where my deployments are, and later we'll be able to see prod instance in here as well. Okay, so let's jump to the StackHawk UI, and I'll pass it over to Zach to tell us more about that.
Great, thank you. Okay, so when you log into the StackHawk UI, the StackHawk platform, this is kind of the first screen that you'll jump into, which is the scan results. And this is just showing you all of the scans that we've recently run through time. You get a brief summary of when it was completed, brief summary of the findings that it discovered, the application name itself, the environment that it ran in this case it was development. And if I click into one of these, this is actually the last scan. This is the scan that Andrew just ran. Get a little bit of summary information about it. Here again, here's the endpoint that we're hitting when this was completed, summary of the scan results. And here you see these are different ways that we've triaged some of these issues. So we've already assigned several issues. We've accepted the risks on several issues that the scanners found. This bar graph up here is just a nice little visual indicator of the way you've handled any issues that it's found. So we've got red for high, yellow, green for low, and gray for anything that has been triaged in any way. And then in the scan details, you can see, I'll just jump over here first. These are all the paths that it has discovered to scan. So these different endpoints like compete and robots and sitemap, etc. And in the findings, summary of each of the findings. So there's a anti-cross-site request forgery token scanner that found a couple of high criticality vulnerabilities and some lower vulnerabilities as well. So I want to jump in on this high criticality issue right away. And let's nip that one in the bud. So you can see here we've got, again, some details, what category of vulnerability this is, a nice description of what the issue really is, which is that it found a form library where you could send in a form without an anti-CSRF token that would make the form easier to hijack by other users or or forged by other users. There's also a cheat sheet you can click into that'll show you even more detail about that and mitigation methods and so forth. So what I want to do is I'm going to take action on all of these paths, and I'm going to send this issue to JIRA. And what you'll see here is this is going to create a ticket for me in JIRA. It automatically comes up with a nice title for the issue, very descriptive, lots more detail in the body, and a link actually back to this page where you can look at the information in more detail. So let's create that issue. 2 paths sent to JIRA. I'll go over to JIRA, and if I hit refresh, you can see that that issue has come up. I want to go ahead and start working on that, but let's just review again the details on this. Found a high criticality issue. Here's the paths. I can click back here for more details and so forth. Okay, so it turns out that I've actually already set up a pull request for this one. And what I'm going to do is I'm just going to remove this jQuery library because we don't actually use it, it turns out. And if you're curious, what that comes down to is really just removing the jQuery library and removing a reference to it in the template, in the layout template for all of the pages. So I will review that. Looks good to me. Approved. Come on. Maybe I can do it from back here. Just going to merge it. Okay, so pull request has been merged into master, and that is going to kick off this GitHub action workflow, which has already begun. And this is going to go ahead and build that container and push it up to Docker Hub. And once it's gone into Docker Hub, that's going to kick off the Spinnaker pipeline automatically. I want to drop back here now to the StackHawk platform again and explore this a little bit more fully. So jumping back to scans and this scan detail for the last scan that Andrew ran, you can see that the 2 new findings, I've assigned them, so they've gone into the triaged bucket. So I no longer have any high alerts. They've been assigned. If I click into one of these, I want to find a good one for demonstrating server leaks information. So if I click in and look at the detail on this, I'm going to show you some more about this. I can click on one of these paths, and over on this right pane, I get some more detail about what this issue really is all about. It's basically the evidence for the issue. So here we see the request. I've got the full GET request, the URL that it hits, the request header that the scanner sent in, and then here's the response that we got back. And StackHawk is calling out the detail that gives the scanner a clue that there's an issue here, and that issue is that we're leaking information about the version of the server that we're running. And this is actually the ingress controller that's used to front end the application in the Kubernetes cluster. Another cool thing you can do here is validate that issue by recreating it with curl. I can just copy this to the clipboard and fire up iTerm here, go to social fonts, run that curl command, and I actually get the output. Now I scroll to the top of it and we can verify that, yes, indeed, that information is there. So we verified that that's a real issue. So I can assign it as a ticket. So that's that. That's some of the scan details. If I go back here, I can see that the pipeline, the Spinnaker pipeline is kicked off. We've started this scan. In a little bit, we should get all the details for the new scan and see if we actually fixed that bug. While we're waiting, I'll go into the applications pane. And from the applications pane, this is a summary of all of the applications that I've set up in the StackHawk platform. And each one of these, has a card that kind of gives you an overview of the security profile and the scan summary over time for each environment. So for this application, for instance, I've got 2 different environments that I've been scanning in: integration and development. And there's this bar graph that shows the profile over time. Let me focus in on the RPS application that we're working on. So this shows you, okay, we've got the development environment for the RPS application, our latest scan, the latest scan summary, and as well as the triaged issues. And this bar graph in each card shows you, each of these bars represents a single scan. So this will fill in over time, and the one over to the right is the most recent scan. And of course, as you've probably guessed, the red component of the bar graph are high alerts, yellow is medium, green is low. And then these gray bars down below the axis represent issues that we've triaged in some way. And so we've been triaging and accepting these issues and working them down over time. I want to also click over to integrations to show you that from here you can get to lots of different integration documents that describe how to integrate with different CI/CD platforms. And we've got a growing number of those, including Spinnaker that's hot off the presses. And we're adding more every day. So far, we haven't found any platforms that have any trouble running our scanner. We've also got some notification integrations. So Slack, which I showed you, I think. We've got an integration with Slack that'll show you when scans start and when they complete, and a little summary of the results that they've found. We've got an integration with Datadog so that you can send events to Datadog and they'll show up as basically log events, so you can track those over time and do analysis through Datadog. And finally, project management with Jira, so that you can share these issues among your team and increase visibility and get people working on them. You can invite other users to your organization. Just enter an email, they'll get a magic link, they can go sign up. We've got our documentation, the announcements of features that we're constantly releasing. And over here, you can look at your own profile information, set your password. If you've got a local credential store, you can get access to your API keys and create new ones. You can change your organization name, look at your billing details, check on your members and see if you want to remove any of them or add any of them, and so forth. Select whether or not you'd like to receive our weekly bulletin on your scan activity. So that is that. Let's go back to the scan results. And yep, so here we are. We've got our new scan results. And it looks like indeed we have resolved that issue. It's not showing up in the list anymore. If it was still there, even though we've triaged it, it would show up still as a high alert in here. It just would be not new, and it would show that it had been assigned. So I believe that is that. I do want to point you also to our documentation. We've got a full set of documentation that you can use to learn everything about HawkScan, really detailed, all of our configuration options. And there's a quick get started guide where you can run through this quick start, and literally in minutes, you can have a quick scan of, say, you can hit example.com. It's a very easy place to start. You can also sign up for our, if you hit get started, you can just sign up. It's as easy as plugging in your Google credentials or create a new password. We do have a new free tier for developers, unlimited scanning for a single application, and I'd encourage you to give it a try.
Sweet. So let's wrap up. And where can we learn? So Zach already shared some additional details. Where else can we learn more information, Zach?
You can head over to stackhawk.com for a clearinghouse of information about the product. You can read the Hawk docs, all of our CI/CD integration guides, and get started with a free developer account that we just launched, that free tier. You can always contact me on Twitter at @zconger. Happy to answer any questions.
Likewise, I am available at AWay168. We have an upcoming webinar with Splunk about DORA metrics. And if you want to learn more about Spinnaker, check us out on armory.io. And there's also links to how you can get started below too.
And I want to give a shout out to that Miniker utility. If you have not used Spinnaker before, it's a really, really great way to get started and give it a try, because it pops up a small instance of Kubernetes for you. You can just run it on an Ubuntu box or something, fires up Kubernetes and installs Spinnaker on it, and it's just ready to go. And it's really great for testing.
Thanks, Zach. Yeah, definitely getting a lot of people using Spinnaker to get started with Spinnaker. So check that out.
Does anybody have any questions? Oh, looks like we've got a couple out there. Oh, no, I'm sorry, we don't.
Everyone is certainly welcome to drop any questions they may have in the chat. Zach, I know one question we get a lot is, what kind of apps can I run StackHawk against?
So it's especially well suited for REST API services. And you can hit more traditional web applications as well. You can hit single page applications. Although for a single page application, a single page application usually is a front end that runs in your browser hitting a back end API service. And in those environments, we always recommend just hitting the API and skipping that front end. You can also, well, that's basically it. And it's got a ton of authentication options as well. So you can hit anything that's token-based authentication or cookie-based or session-based, form-based. We really haven't run into anything that we can't authenticate against. And that's useful because then it gives the scanner access to more paths that it can discover and exercise.
Awesome. Well, and Andrew, one question for you. I know with StackHawk, when we get new folks up and running, it takes about 15 minutes from login to first scan. Can you talk to us a little bit about that getting started process with Spinnaker or Miniker?
Yeah. So all you have to do is just go to the repo github.com/armory/Miniker. There we have a script that you can run inside a VM that will automatically download and install essentially a sandbox environment of Spinnaker for you to get started. We have some other YouTube videos that you can use to learn how to build pipelines as well. A lot of those links can be found on our website and docs.armory.io.
Awesome. And how long does that take on average? Do you know?
It can vary depending on your understanding of Kubernetes as well as the infrastructure. But with our help, we do have accelerated ways of running POCs with customers, proof of concepts that can help you accelerate your path to learning. Otherwise, usually getting started with Spinnaker, it really only takes less than half an hour to get Spinnaker up and running. It's just right now learning how to use Spinnaker can take a few days with our guidance.
Awesome. All right. Well, if we don't have any more questions, we can certainly jump off. And if anyone has any follow-ups, feel free to reach out to Andrew and Zach on Twitter. And we'd be happy to talk to you some more.